Hello again. We're going to be dividing complex numbers, and basically we have a problem with two terms in the denominator and one term in the denominator. With complex numbers it's a little different. This one would be more familiar to you. A lot of students would be tricked on this one. With this one, all you got to do is multiply by the conjugate, if you remember what that is. It's basically the same thing as the denominator, except it has a different sign. So it's 2 subtract 4i, but what you do in the bottom of an expression, you always do in the top, or denominator, you do in the numerator. So it's 2 subtract 4i. And let's go ahead and do that really quickly. 3i times 2 is 6i. 3i times negative 4i is negative 12i squared. And that's actually going to end up being plus 12, because I squared is negative 1 by definition. Negative 12 times negative 1 is 12. I'm not going to do that just yet. Over 2 times 2 is 4. 2 times negative 4i is negative 8i. 4i times 2 is positive 8i. And 4i times negative 4i is negative 16i squared. I'm going to go ahead and simplify it all at the same time. So this is actually 12, because negative 12 times negative 1 is 12. I'm going to put that first. Plus 6i over, these two terms cancel out, and negative 16i squared, and I squared is negative 1. Negative 1 times 16 is 16. 16 plus 4 is 20. Not quite done just yet, because I can factor out a number. And what can I factor out of 12 and 6? I can factor out a 6. When I do that, I've got 2 plus I. Check it if you want to. 6 times 2 is 12. 6 times I is 6i over 20. And 6 over 20 reduces to 3/10. So it's 2 plus I over 10. And then it's arguable what you can do. You can actually circle this at this point, or you can make it 6 plus 3i over 10. I'll go ahead and show you that way too. But this answer is actually what I would prefer. But I know there's some teachers who wouldn't. So that's 6 plus 3i over 10. 6 over 10. Yeah, that reduces. Why did I do that? Oh, no, I didn't, pardon. Woo. 6 over 10 plus 3i over 10. 6 over 10 is 3/5 plus 3i over 10. That's the other answer that you can have. Ooh, almost there. Fortunately not though. So you divide by that, yeah. I would prefer this answer though, because it's still in factored form. Some people prefer this answer. It depends. I guess if you're an engineer, maybe you prefer this one, but in terms of just regular math student who's just taking algebra, that one's fine. Okay, maybe that was too long for that one, but I'll keep going anyways. Erase this so that I can go ahead and do this one. Now this is a good question, the second one that I posed, and I'll show you what I mean. I ask students what to do here, and sometimes they're a little muddled at what to do, and the answer is you multiply by I. And some students say, well, I don't get why you multiply by I. Well, you multiply by I because multiplying by I will turn it into a number, not an imaginary number anymore. I'll show you. 5 times I is 5i. I times I is I squared over 2i squared. 5i, I squared is negative 1. 2i squared is negative 2. That's it. And we're going to actually put the number before the imaginary. So negative 1 divided by negative 2 is 1/2. And 5i divided by negative 2 is negative 5i over 2. That's the other way to write it. You definitely wouldn't leave the negative in the denominator. And actually for this one I would prefer that. I don't think it's too difficult of a step there. So that's that. You can also put the negative there and make this a negative 5i plus 1 over 2. That works as well. But that works too. Okay, so that's dividing complex numbers. Hopefully it's helpful. You know, I mean, people find it useful, but it does have its uses. It's pretty cool. Take it easy for now. Goodbye.